So we've seen one way of combating stomach acidity, which is by neutralizing excess acid. Another way to combat stomach acidity is to inhibit the production of stomach acid. And there's two ways that these acid inhibitors act. One is by H2 blockers, so some of them are H2 blockers, and some of them are proton pump inhibitors. Now let's see how these H2 blockers act. So normally in the stomach, secretion of acid is triggered by histamine. And histamine binds to H2 histamine receptors in the cells of the lining of the stomach. So let's try to draw this. So let's say this is the wall of the stomach. So this is a histamine receptor and this is histamine. So the histamine will bind to the histamine receptor and then it's going to secrete acid. There's another cell in the lining of the stomach that will secrete acid. Let's say it looks like this. Now, when we take drugs like Zantac or ranitidine, this is going to compete with histamine receptors for binding at the H2 receptor, which means that instead of histamine, we're going to have ranitidine, which will bind on the H2 receptor. And when ranitidine binds here, it blocks the release of H+. So now you can see that there is no H+ that is produced. So it prevents the release of stomach acid. This is called an H2 histamine receptor inhibitor. So it inhibits the histamine from binding on the H2 receptor and provides short-term relief from symptoms of excess acid. But it requires frequent administration because at one point the inhibitor is going to leave that site, that receptor site, and then histamine will again bind and acid will be produced. So now we've seen the H2 blockers. Now let's see proton pump inhibitors. Now in the stomach, there is a proton pump. So a proton pump is going to secrete proton into the stomach. So it's going to release H+. So if we have to draw it, so in the wall of the stomach, you have the proton pump. Remember we drew here, this is the proton receptor, the H2 histamine receptor, and here you have the secretion of H+. So let's say you have the cell here, which is the proton pump, and what happens when you have omeprazole and esomeprazole or Nexium, this is a very famous drug. So what it does, it inhibits H+ pump, which is responsible for H+ ions in the stomach. So what it does, it's going to inhibit the pump. So it just gets into the site and inhibits the secretion of H+ ions, which means that you're not going to have as much acidity in the stomach. And this is effective up to 3 days. So you don't have to take it as regularly as those H2 histamine receptors, those H2 blockers. Now, omeprazole and esomeprazole, these two molecules, they are very similar to each other. They have the same molecular structure, but they are mirror images of each other, as you can see here. Enantiomer basically means one of the isomers. So isomer 1, if we can simplify, isomer 1, isomer 2. So they are mirror images. So they are non-superimposable. So you cannot superimpose this on this molecule. They are non-superimposable mirror images. Now, omeprazole is a racemic mixture. Racemic mixture means that it contains both isomers. So, omeprazole contains both omeprazole and esomeprazole. But esomeprazole is a single isomer, so only one of the mirror image. But both of them, they are as effective as each other. They both have low polarity. They easily cross the membranes and enter the cell compartment containing hydrochloric acid. In the acidic environment, they produce the same active metabolite that binds to the proton pump enzymes and reduce the production of H+. Hence, they are both as effective and do not need to be administered regularly as the H2 blockers.